Hello, Principal sir, can you hear me? Hello, am I audible, Mook? Hello,
Yes, sir, you are audible.
yeah. Principal sir, so it's the time is 2:55, I think. So we'll start after 5 minutes. I would like to request Professor Luciano to, is it possible to share your screen now, because at 3 p.m. we will start the program. Uh, Professor Luciano, can you hear me? Hello.
Hello.
Hello. I think Professor Luciano can't hear me. Okay, let it be, no problem. So we will start our program just after 5 minutes, because officially we have announced that today's webinar will be started at 3 p.m. So we'll start at that time only. So please wait for that. Hello. Mr. Moyuk, am I audible?
Yes, sir.
Yeah. Professor Luciano. So I
Yes, I'm
think
here.
yes, our speakers are also joined and he is available. Our honorable principal sir has also joined, and it is
Perfect.
2:59. So we will start the program. Already
Yes,
more than 150 participant had joined in
perfect.
our webinar. So dear participants, my colleagues, today's speaker Professor Luciano Sasso, our honorable principal Dr. Amit Shankar Dotto, and participants from the other institute across India. I welcome all participants and my colleagues in this webinar on behalf of Eminent College of Pharmaceutical Technology, West Bengal. Today, we have organized a webinar on the topic of pharmacological modulation of oxidative stress. So before moving to the main part of the today's webinar, our honorable speaker, Professor Luciano Sasso, who is the very well-known person with a vast research experience on this particular field of oxidative stress inflammation. And very specifically, I would like to say he has a uh, very he has very vast experience and expertise on neurodegenerative disease. So before moving to our webinar, I would like to request our all participants, if you have any question, please type your question in our chat box, and please don't switch on your microphone or on your video. Only our speaker sir, he only will speak and his video will be only switch on. So again, I'm welcoming all. Today's webinar is organized by the Seminar and the Conference Committee and the Internal Quality Assurance Cell of Eminent College of Pharmaceutical Technology. So I welcome Professor Luciano Sasso, and I would like to request our principal sir, Dr. Amit Shankar Dotto, to introduce our today's speaker, Professor Luciano Sasso, to all participants. Principal sir, please.
Hello. May I audible?
Yeah, yes, sir. You are audible, and please, sir.
And good afternoon, Professor Luciano Sasso. He is a renowned personality in this pharmacy field and medicines. He is also member of the Faculty of Pharmacy and Medicine, Sapienza University, Rome. He has experience for last 25 years. He has a vast experience in this field. He's published so many individual papers, author of more than 250 original scientific articles published in the peer-reviewed international journals. With impact factor, H index Google Scholar 51, H index Propensia 41, and total of factor more than 800. Working mainly in the field of pharmaceutical modulation of oxidative stress. He coordinates several international research projects and has been referred for many national and international funding agencies and international scientific journals in last 25 years. So we are very pleased and proud to be such a big name who has delivered a speech and also share his experience with our participants. And in future, we also they're jointly doing some projects like this with his guidance. And so by this word, thank you, Professor Luciano. You just give me your speech.
Perfect. So good afternoon to everyone. Many thanks for the invitation. I would like to thank the principal of your college and also Dr. Biswas for the very kind words of introduction. So without further ado, I will start to share my screen and make my presentation, and then at the end I will open my presentation for discussion. So please feel free to ask questions in the chat, as it was said. So I'm going to share. Okay. Okay, I hope you see my screen now.
Yes, sir, it's visible.
Okay, perfect. I hope you.
Yes, Professor Luciano Sasso, please, I would like to intervene. So, dear participants, please type your question in chat box, but please don't type the good afternoon, good evening this, because then we will get puzzled to find out the question. So please only type the question in your chat box. Thank you, sir. Sir, please proceed.
Perfect, thank you. I hope you can hear me well. So it was said, I'm a professor of the Faculty of Pharmacy and Medicine of Sapienza University of Rome in Italy. Sapienza is a large university. This is our website. Also, we have a website in English if you are interested, and this is one of the most important universities in Italy. I had the privilege to visit India several times, thanks to a bilateral project that we had a few years ago. And so I hope that also following this talk, we will be able to implement some other collaborations in the field of oxidative stress with some of the colleagues. So very briefly, I kindly ask everyone to close the microphone. I think there is a microphone open still, so please close the microphones. So very briefly, when we speak about oxidative stress, we have to remember which are the main actors in this phenomenon. And of course, we start with the reactive oxygen species. This is the list of the most important species, such as superoxide, hydrogen peroxide, hydroxyl, and many others. The main reactive nitrogen species are nitric oxide, the nitrogen dioxide, peroxynitrite, and many others. And also, it is important to also reflect on the type of antioxidants that we can consider. This is a publication that I have from a few years ago that you can find easily on the internet, or I can send it to you if you don't find it, with my colleague, Professor Firuzi in University of Shiraz in Iran. And then at that time, we divided the antioxidants in 4 different categories based on the molecular weight and based on their nature, whether they are exogenous or endogenous. So typical endogenous low molecular weight compounds are glutathione, coenzyme Q10, uric acid, melatonin, bilirubin, etc. Then we have several high molecular weight antioxidants of endogenous nature, which are several, very famous enzymes such as superoxide dismutase, catalase, glutathione peroxidase, and many others. Then also very famous are some small molecules of exogenous nature, which are typically polyphenols, so flavonoids, resveratrol, lipoic acid, etc., which have been studied in the last 30, 40 years extensively. So there are thousands of publications on them. And then more recently also, there have been several groups studying pegylation, of course, of some enzymes such as superoxide dismutase, polyphenolic polymers, etc. So this field is a bit less studied, but also it is interesting because by pegylation, for instance, you can change the pharmacokinetic properties of enzymes. Concerning the diseases in which oxidative stress is involved, of course, we know that there are many, such as cancer, neurodegenerative diseases, atherosclerosis, chronic obstructive respiratory disease, rheumatic disease, diabetes, cataracts, and others. The problem is that very often we are not sure whether oxidative stress is the cause or just a consequence of the disease. This, from the pharmacological point of view, it is essential. Of course, it is important to target oxidative stress from the pharmacological point of view only if it is the cause of the disease. Otherwise, it doesn't make much sense. And this is something that very often we don't understand, and this is something that we have to study actually better. Oxidative stress has been studied really extensively in the last decades. If you look on the clinicaltrials.gov website, you can find more than 4,000 studies, just putting in the keyword antioxidants. meaning that's really, there was a big effort to try to actually study in humans this phenomenon. The problem is that very often we actually experience failures. I mean, very often the clinical trials that have been tried, actually they were not effective, and they did not bring the results that we were hoping. And there are several reasons for that. In also the paper with Professor Firuzi on pharmacological applications of antioxidants, lights and shadows, we try to summarize the main reasons why so many failures have been experienced. And some of them are in this picture. So basically, we know that sometimes oxidative stress is not sufficiently controlled by the therapy. Oxidative stress is not the main cause of disease. Drug lacks the appropriate mechanism of action. The therapy started too late. Drug interferes with the ROS physiological functions. A single drug is not sufficient. Target is not engaged. So these are some of the reasons why, in many cases, antioxidants were not effective in the clinical trials, which, we tried. But also there are some lights. I mean, I don't want to be so pessimistic about, this field, since, we work in this field quite intensively, and we have to also, notice that there are some also, positive aspects. Such as, for instance, the antioxidant therapy for chronic obstructive pulmonary disease, COPD, with N-acetylcysteine, which had some beneficial effects. Flavonoids and other polyphenolics actually showed also beneficial effects in osteoarthritis and certain vascular diseases. Antioxidants such as N-acetylcysteine and melatonin were effective in reducing the autotoxicity of aminoglycosides and platinum anti-neoplastic drugs. Allopurinol, an effective inhibitor of axanthin oxidase, seems to be useful in perinatal asphyxia and in some conditions of ischemia reperfusion injury. And of course, the research in cardiovascular diseases and diabetes is very effective, and probably very soon also there some new molecules will come up. But we have to admit that in the last few years, there was a big change in the field, because the classical approach that was proposed several decades ago of radical scavengers, with antioxidant activity is not true anymore. I mean, we cannot believe anymore that just a molecule capable of scavenging radicals can have beneficial effects. And there are several reasons why we actually change approach in the field. One of the reasons is, for instance, when we take polyphenols, in our body. So when humans or other animals assume polyphenols, of course, you assume a compound that in vitro showed a very strong antioxidant. But then the bioavailability, which means the amount that actually reaches our blood, is very poor. So we actually have, even ingesting quite high amounts of polyphenols, you may have in the blood of humans a concentration of about 1 micromolar, which is very small. Consider that uric acid, which is a quite powerful antioxidant of endogenous nature, is about 60 micromolar. So this addition of 1 micromolar cannot justify a very significant effect on our health. And this is one very important argument against the idea that just the scavenging activity of polyphenols can play a role. So more recently, actually, most of the work in the field was focused on pathways. So we believe that many molecules which were studied in the past as scavengers, actually they modulate some pathways, such as the NRF2 pathway, the nuclear erythroid related factor 2 pathway, which is a transcription factor and master regulator of the endogenous cellular antioxidant defense system. In a few words, we have to say that NRF2 is usually inactive in a complex with a so-called KEAP1 protein, a Kelch-like ECH-associated protein 1. So in this complex is in the cytosol and it is not active there. But then reactive oxygen species and antioxidants can cause the release of NRF2 and the translocation from the cytosol to the nucleus. And there, NRF2 can bind an element called antioxidant response element. And then after that, we have the promotion of several antioxidant enzymes such as catalase, glutathione peroxidase, superoxide dismutase, etc. So this is the very powerful mechanism because small amounts of polyphenols can actually activate NRF2, can actually induce this translocation of NRF2 from the cytosol to the nucleus and have this very strong antioxidant enzyme effect. It's not anymore a scavenger effect, but is the indirect effect of the enzymes which are induced by NRF2. So this is a figure explaining just what I said. So you see here in the cytosol, this complex NRF2 KEAP1, which is not active. Then we have the activation of NRF2. NRF2 moves to the nucleus, binds to this element ARE, and then we have the promotion of several antioxidant enzymes. But the very interesting thing here is, as this table comes again from this publication from 2014, basically you can see many molecules which have been studied for a long time as scavengers. Actually, they are modulators of NRF2. This is really amazing. And they act by different, actually, mechanisms. So we can have some micro reaction acceptors. So molecules like curcuminoids, cinnamic acid derivatives, ferulic acid derivatives, some coumarins, chalcones, flavonoids, triterpenoids, etc. All these molecules are actually scavengers, in vitro, so they can act in models of radical scavenging. But they are also activators of NRF2. As I said, this mechanism of activation of NRF2 is more powerful than just the scavenging activity. Same for other molecules like lycopene, alpha lipoic acid, and many others. So if we screen many scavengers of radicals, which have been studying as radical scavengers for a long time, actually there are very effective NRF2 activators. Also, resveratrol, as you know, resveratrol is very well known, very well studied molecule. And it is, of course, a very strong scavenger in vitro of radicals, but also can act on the KEAP1 NRF2 pathway and also on the SIRT1 pathway. So we believe that this is the real mechanism of action of resveratrol in vivo. This is another example when we look at molecules like caffeic acid, phenylethyl ester, curcumin, quercetin, and others like naringin, carnosic acid, etc. They act on the NRF2 KEAP1 pathway, but at different levels. So the specific mechanism can be a little bit different, but the final effect is translocation of NRF2, and then in the end, stimulation of the promotion of different enzymes. Another interesting point is this NRF2. So it's not always good, because until now we are thinking of NRF2 as something very good because we activate NRF2, we promote antioxidant enzymes, but sometimes can also be evil. And in the end, this is, you see, is a figure from the Roman civilization in which there was this god called Janus. Janus was a god with two faces, a good one and a bad one. And actually, if you look at the word in English, January comes from this god, Janus, because January is a month which looks ahead in the year, but also is the first month of the year, so also can look back. So it's an interesting god that remains also in our culture. And in this case, what I mean is that NRF2 can be good and bad depending on the conditions. So when we look at carcinogenesis, in the very, very early phases, it is good to have activation of NRF2, so to probably to have a good diet with polyphenols, fruit and vegetables, etc. Because these molecules, they are actually good inhibitors of carcinogenesis, also thanks to the activity of some of their compounds in activating NRF2. But if NRF2 is actually very active in some cancers, this actually becomes a very bad phenomenon, because NRF2 can also assist malignant cells to defend against excessive oxidative stress, chemotherapeutic agents, and radiotherapy. So basically, in the end, hyperactivation of NRF2 becomes actually something that we don't want to happen, because during in cancer. And also this concept, I mean, if we reflect on this concept, it's not so unexpected, because if you look at classical chemotherapy, most of the drugs that we use against cancer are molecules which are pro-oxidants. So this is a table that, again, you can find easily on this publication, but otherwise I can also send it to you. It's a table in which you can see that molecules like busulfan, carmustine, cisplatin, etc., by different mechanisms. I'm not going through all the details here in this table, but they are pro-oxidants. So it was probably wrong a few years ago to think of using antioxidants in cancer therapy. And actually, they were not effective, and they were even dangerous. There are studies in which it was observed that the use of antioxidants actually increased the mortality in the treated group. And in this figure, we try to understand again why this happened in this phenomena. So when we induce oxidative stress with a chemotherapy, we have to compare normal cells with typical cancer cells. In blue, you can see the intrinsic oxidative stress of a normal cell and the typical cancer cell. You can see that it's higher in a cancer cell. So the intrinsic oxidative stress in blue, it is higher in a cancer cell compared to a normal cell. Then you increase the oxidative stress using therapy, using pro-oxidants. You can bring easily a cancer cell to apoptosis, increasing the oxidative stress without killing the normal cell. You see, because you don't reach the threshold for apoptosis, just treating with the same amount of pro-oxidants, cancer cell and the normal cell. And this is a similar picture. So in this picture, you can see, tissues from normal tissues to neoplastic transformation, carcinoma, and invasive carcinoma. And then you can see on the left, on the y-axis, the levels of reactive oxygen species. And they increase, they are higher and higher. So basically, the level of ROS, of reactive oxygen species in invasive carcinoma is much higher than normal tissue. So it's easier, if you look at the red arrows, with the therapy, with the cancer therapy, using pro-oxidants, you can easily kill the cells in invasive carcinoma and without actually killing the normal tissues. In this picture also, you can see that when NRF2 is inactive, and then you activate NRF2 in the very early phase of carcinogenesis, this is something useful. So the green part means that you can scavenge xenobiotics, carcinogens, ROS, etc., preventing the damage of DNA or proteins, etc. So this prophylaxis that probably we can do with a good diet, with a diet based on polyphenols, fruit and vegetable, etc. This is useful. But then when the cancer is already there, and then you have already some lesions, you may observe NRF2 amplification. So when NRF2, due to different reasons, is activated and remains activated for a prolonged time, then in that case, it becomes actually something very negative for the cancer. And why this happens? It happens because the overexpression, hyperactivation of NRF2 can cause enhanced cell growth, increased survival, promotion of metastasis, and chemoresistance. So these are some of the mechanisms by which NRF2 during the hyperactivation can actually play this very negative role. And this is another example from another paper that I published in 2017, in which you can see, activators are actually good in the early phase, but then when we have a progression to more malignant disease, then you need to use inhibitors of NRF2 in cancer therapy. So in a few words, the situation is complicated, it's not easy, but we need to actually evaluate the level of oxidative stress in different diseases, in different tissues. We need to develop better markers, and then we can see that sometimes it can be useful to have antioxidants, but in some other case, we need pro-oxidants. So I think we need to develop, better molecules and use them in the proper way, depending on the conditions. Concerning NRF2 inhibitors, already there are some examples in the literature. We are working on some of them, compounds like brusatol, creatine, apigenin, etc. These are molecules which showed inhibition of NRF2. As you can see, it's not easy, the situation, because some, for instance, polyphenols, they can be activators or inhibitors of NRF2, depending on the different conditions. So it's not an easy field to work with. So we are working quite hard in cooperation with several colleagues. I want to thank very much Professor Firuzi in Shiraz University of Medical Sciences, my colleague Emiliano Panieri, Pelin Terkoparan, Achillear, Sibel Susan, Matej Sova, and many others who are working with me in this field. I also want to invite you to attend some webinars that we are organizing. These are completely free webinars. You just need to register on the biochemical and pharmacological aspects of oxidative stress. Please join us. If you go on the website antiox.it, you will see there are really high-level speakers. Yesterday we had one of these webinars with attendance. And also I invite you to look at my ResearchGate profile. There you can see some of the publications I mentioned in this presentation. And I think especially for young people, ResearchGate can be very useful to connect, to share knowledge. And again, this is a free website. I also want to invite you to contribute to some of the special issues that some guest editing. We have a deadline at the end of October for this journal, Frontiers in Cellular Neuroscience. It's a good journal with the impact factor 5.5, Foundation Molecules, 30th of November, Frontiers in Oncology 6.2. So there are many opportunities to actually publish in these very good journals. And this is my email address. If you need additional information, do not hesitate to contact me. And I thank you very much for your attention.
Thank you, Professor. Thank you, Professor Luciano, for your valuable lectures in this antioxidant field. So I think from this, the more the participant who are listening your lectures, they will be benefited, and if in future they'll make some contacts or write up in your journals or like this, that is a very clear gesture for doing something. Thank you.
Is there any question from the participants? So please, you can type in our chat box, so then we can interact with Professor Luciano, because Professor Luciano is a very renowned scientist in this field. He has managed his time to deliver this webinar in this lecture in the field of oxidative stress. So is there any question from the participants? So please, you can ask. Please type your question in chat box. I think no question. So Professor Luciano, there is no question from the yes, one question from the participants.
One came.
Yes, sir. Yes, sir. One question is there. The question is from Arijit Shil. He's asking troubleshooting Mikkel's addition of bis aminopropyl PDMS and PEG acrylate.
It's a very concise question. I mean, I really would like to ask you to ask your questions in a bit more extensive way, so to clarify what you mean. What are you? So you, I think this colleague has some problems in doing this reaction, if I understand correctly. But I really invite to ask questions in a more appropriate way to clarify what is the main point you want to.
Yeah, the question is not clear. I think the motive of the question
is
is not
very
clear.
I mean, I don't know. Maybe I invite the colleague to send me an email. Maybe this is easier. Then we can go deeper. Because if it is something very specific, maybe it's not interesting for everyone. But the colleague can also send me a message. I can also send in my, I put it in the slide, but I also put it in the chat. My email address, so you can contact me via colleagues. I would be happy to also to start new cooperations if you want.
Okay. So then there is no more question. Yes, there is no question.
I can also send you the I can also send you, as I said, which is the website for that I mentioned for the webinars. I think especially for colleagues working in the field, that can be very useful. So this is the program.
Yes.
And then I can also send my ResearchGate profile, so people can have it.
So, dear, I can say, dear participants, that Professor Luciano, he has published more than 200 articles, as our principal sir in introduction said. And please notice his page in ResearchGate and the website of Antiox in that website. So the amazing thing is his impact factor, total impact factor is, I think, more than 500. So it is really a tough job.
More than 800.
More than 800. Yeah. So it is really a tough job for a scientist, but he is a really renowned scientist in this field. And as there is no question, so I would like to thank Professor Luciano to provide his valuable time with us and for delivering his really very exciting lecture on the field of oxidative stress. And I have also learned the many things, because this NRF2, this is the new idea, as Sir told, that scavenging, that concept is going to be changed. So this is very important. So with this, I would like to thank Professor Luciano, and with this, I would like to conclude the today's
Kaushik sir.
Yes.
Sorry for the interruption. There is another question from Arijit Shil.
Okay. Sorry.
I can invite this colleague, as I said, maybe to send me an email, so we can go a bit deeper on this question, because they're very specific and maybe they're not interesting for everyone. But again, the colleague has my email address, and it would be a pleasure to be in touch with him.
Okay. So with this, yes.
Maybe I can propose, Dr. Biswas, maybe if we can stay online, maybe with you and with the principal for a few minutes, just for a follow up and see also, to talk about possible collaborations.
Okay. So dear participants, with this we are concluding our today's webinar. I would like to request our technical coordinator, Mr. Moyuk Sarkar, to give the this feedback form and the certificate form in this chat box, and we will send the feedback link to your email also. So please, all other participants can leave the webinar meeting because we are concluding here. So thank you to all for participating and being with us in this webinar. So please, you can leave the webinar. So dear participants, you can leave the webinar as we are concluding the webinar here only. And our faculty members can also leave because there is no need to stay. Only principal sir and I will stay here to talk with Professor Luciano in other matter.
Kaushik sir, can I stop the YouTube live?
Yeah. Please stop the YouTube live and all recording.